Alright, let's look at the homework 4.6, problem number 5. Alright, so a candy box is made from a piece of cardboard measured 27 by 15 inches. Alright, then cut off the square pieces from each corner and make up open box. Alright, so let's look at that. We just need to probably draw a picture. So you start with 27 by 15. So you have a rectangular cardboard. Alright, then cut the corners off the square pieces. So it goes something like that. Cut those off. Alright, then fold this four walls up to make open box. So it's going to look kind of like this. So let's see, maybe it's going to probably look something like this. Right? Right, something like that. Alright, so let's find the volume of this box. Alright, so let's say we're gonna give, let's see, I'm gonna say x. So let's cut out the x by x square pieces. Alright, so since candy box is made from a 27 by, so 27 inches here, then 15 inches here. Alright. So since you're cutting off x pieces on both ends, so you're actually cutting off two x's. So here it's a 27 minus 2x, right? And this would be 15 minus 2x, right? Then height is going to be x, right? So the volume of this open box would be simply 15 minus 2x times 27 minus 2x times x. Right? So that will be the volume we want to maximize, and we just have to multiply these guys out. Right? So the big numbers. Let's see, 27 times 15. 5 times 7 is 35, and 2 times 5 would be 10, so it's 13, and 27, right? So 504, right? So that will be 405, right? So I'm just, this guy times that guy. Then 15 times negative 2x would be negative 30x, right? Then we do negative 2x times 27, that will be negative 54x, right? Then negative 2 times negative 2, negative 2x times negative 2x would be plus 4x squared, and then you multiply by x. Alright, so if you clean it up, let's see, I'm going to do x times 4x squared. You get 4x cubed, right? Then let's see, this is going to be, I'm going to just combine these guys together. So it's negative 84, negative 84. X, but you multiply by x here, so distribute the x here, so that would be 84x squared, and plus last one is 405x. Alright, so let's take the derivative, and here derivative is going to be, alright, so it's a 12x squared, alright, minus 168x plus 405, right? Alright, I don't think I can factor this out, so I'm going to set that equal to 0 and use the quadratic formula. Alright, so if you look at it, let's see. I'm going to clean this up a bit. Alright, so quadratic formula. So let's see, x is going to be equal to, alright, negative b, which is going to be 168 plus or minus square root of b squared, so negative 168 squared, minus 4 times a, which is 12, times c is 405, right? Then divide by 2 times a is 12, right? So let's get these values, right? Then let's see, I'm gonna bring out the GeoGebra here. Alright, so let's see, I'm gonna just get oops. Alright, so let's find that value. Parenthesis 168. Alright, I'll do a plus 1 first, then square root of. Alright, let's see, negative sign doesn't really matter, so I'm going to just do 168 squared minus 4 times 12 times 405, and divide the whole thing by 2 times 12, so 24. Alright, so this is 10.991. Alright, obviously that's going to be too big because you only have 15, so you can't do that. And I'll do the minus version, alright, which is parenthesis 168 minus square root of 168 squared minus 4 times 12 times 405 divide by 24, alright. So this gives us 3.09, right? So this is more like it. So when x equals 3.09, that will be the maximum, the box with the maximum volume. All right, check that. All right, that's it. I hope that this was clear. All right, so this was the answer.